Hey everyone, Chang here and welcome to my channel. Now, for today's video, we're going to go over this. Now, if you guys can't tell already, this looks almost like the equation of an ellipse, but it's not an ellipse. So we're doing the opposite of an ellipse. It's called an hyperbola or hyperbola, right? Depending on how you pronounce it. I've heard it both ways. Now, here's the thing. With hyperbolas, there's actually two generalized equations that you'll end up seeing. This is an example of the equation in two different forms. Now, even though the numbers itself are the same, notice that there's a key difference, right? The x squared and the y squareds are flipped. So, just a very quick sketch, and we're going to go into details on how this comes to be. But basically, at least for this one right here, the hyperbola is going to look something along the lines of, well, this is -3, and it's going to look along the lines of this. Of course, this is not drawn to scale in any way or accurately in any way, but it's going to look something along the lines of this. Where this one right here, all right, same thing with the numbers, except for the x squared and the y squared flip. So you guys can sort of guess, right? This is going to be 3 right here. It's going to be -3 right here. So rather than opening left to right, now we're going to open up and down. Okay. Now, that's a really rough sketch of what these two equations look like. And now we're going to go into details because guess what? There is a lot of vocabularies relating to hyperbola, a lot more than ellipses. And just by going through the vocabulary, hopefully it clarifies a lot of things, because one of the key confusion is just not remembering what each and every one of these words mean. We're going to go over that, then we're going to go over how to graph these, or from this, all the information you need so that you can make even a more accurate sketch than what I just very quickly did. All right, so let's talk about the vocabulary. Alright, so here's the list of the vocabularies that you would normally see when we're talking about hyperbolas, and here's a rough sketch. Now, hopefully this shows up in the camera, I'm not entirely sure, but there's a dotted line of a square, or actually rectangle, and dotted lines of what we call basically diagonals within those, or that extends out of those rectangles. Now, interestingly enough, when you are graphing, the foci or focus points are not nearly as important. So this you can sort of draw from your knowledge of focus or foci, right, of ellipses. A little different, which we're going to spend in more details in a future video. But as of right now, know this. The foci or focus points are usually inside the two hyperbolas, right? It's either here, or if it's opening up and down, then it's going to be around right there. But it's basically on the, not the center, but basically is within the hyperbola itself. So I included the points in red, but let's just label it really quickly. Here's the foci for this side. And of course, there's another foci on this side right here, right? All right, cool. So vertex, right? Vertex is actually quite important because basically think of the vertex of a quadratic equation of a parabola, except for this is a hyperbola. So there's basically two of them, right? This right here is the vertex, which is still like a parabola, the sort of midpoint or the center of the, I guess you could say, the parabola or the curve, right? So here's a vertex. And here's a vertex as well. Okay, so those are quite simple. Now, the new introduction compared to everything else you've learned so far is this thing called co-vertex. Now, co-vertex is slightly different. Now, think of the equation that we were just looking at. This one right here, the equation itself was x squared over 9 minus y squared over 4 equals 1. Remember that this one, because there's the x squared and y squared, the original one, it opened left and right. Well, if we swap the y squared and the x squared, it actually opens up and down, right? So where if it opens up and down, the vertex would be, that's what we call the co-vertex. So here's the co-vertex. Up here, co-vertex with the little dash. I've seen it with or without the dash, so I'm just going to do the dash. And co-vertex is right here. Now, what is so important about them? Well, here's the thing. It actually helps you graph tremendously. So, when we are trying to graph an equation, we find the vertex and then we find the co-vertex. And afterwards, we draw, let me just draw this in red so you guys can see it. We draw this sort of rectangle that is based on drawing horizontal lines and vertical lines where it would cross the co-vertex and the regular vertex, right? We draw this and this helps us tremendously because guess what? First and foremost, transverse axis is basically the distance from the one vertex to the other vertex. That's the transverse axis. So if you have it drawn up and down, right? If the equation requires you to draw the hyperbolas, one going up, one going down, then the transverse axis would actually be the vertical part, right? So it just depends on where the hyperbola is located. Now, what I was saying is the importance of this little rectangle here is it helps us with the asymptote, right? The asymptote itself is basically, well, what asymptote is normally known as, right? Where a boundary where the line can never cross. Well, in this case, there's always going to be two lines of asymptote, and it's going to be from the diagonals of these rectangles right here. So you just draw a line straight through and another line straight through right here. That gives you the asymptote. Okay, so with the asymptote, now you can make a rough sketch of the hyperbola. You know where it's going to open up based on the orientation, and we're going to go into details more about how to read and understand this and draw information from it. But basically, we know the vertex, and we're going to draw our curve as close and getting even closer and closer to the asymptote, never crossing it, never touching it, but as close as possible, and that would give you your rough sketch of the hyperbola, right? And of course, the last one, actually quite important, is the center. And the center is usually, well, where you guys can guess, right? In between everything, that's where the center line or center point is, right? Between the two hyperbola. Okay, so that's just a very brief overview of the different vocabulary that you would encounter when we are talking about hyperbola. I'm going to try to use some of these. I'm not going to go crazy on it to make it confusing, but we're going to go into details given equations, how to get all the information we need so that we can actually sketch the graph. So let's go to that. Alright, so right here I wrote two more generalized equation of hyperbolas, right? We have right here x squared over a squared minus y squared over b squared equals 1. And we have the other one where it's y squared over a squared minus x squared over b squared equals 1. Now, here's the thing. Similar to when I was presenting the ellipses, it's great to have generalized formula. Don't get me wrong on that. But the problem is that when it's so conditionally based, it gets really confusing. And I've seen variations where when they were flipping things, they make this as b squared and this as a squared, and it just gets confusing if you're trying to memorize a formula. Understand where they come from. What's the purpose of it? It's actually a lot easier. First and foremost, when we're looking at a generalized form, the key thing we really have to ask ourselves is what's in front or what is positive, which is more accurate, right? In this case, we have the x squared thing that is positive, whereas the y squared is negative, right? It's in front of the subtraction sign. Whereas in this situation, the y squared is what's considered positive, whereas the x squared is the negative or the subtraction, right? This is key. The reason for that is, well, hopefully you guys can guess at this point from our example, right? Whatever is positive is the direction in which the hyperbola is going to be opening. In this case, if it's the x, that's going to be positive, right? So x, the x-axis, think of that way as the left and right. So if you see immediately that in front is x squared and it is positive, because of course, you know, there's always going to be the teachers who's going to play prank and then put a negative, like a minus y squared over b squared in front just to confuse you. But if it's positive, that's the direction it's opening. X, then it's opening left and right. If it's y that's positive, then it's going to be opening up and down. So that's one of the first key information, right? The second one is this whole idea of a squared and b squared. I don't like it that much. But the idea of a squared and b squared, more importantly, the a and b, right? Those tell you the vertex or the co-vertex, depending. Okay, and that's why it can get confusing when people try to write formulas, and that's why it gets confusing because of the depending factor. Well, here's the thing. If this is opening left and right, and this is under the x, right? The a value is basically from the center, a. From the center, a. That's your vertex. So you can guess the b value in this case where it's not opening in that direction, is your co-vertex. From the center, it's going to be up B. From the center, it's going to be down B, right? Whereas in this case, it's slightly different, right? Since it's going to be opening up in the Y direction, up and down, the A itself is going to be from the center, right? A is going to be going up. That would be its vertex. From the center, A going down, that would also be the vertex. And in this case, the B, in this situation, since it's not in the direction that's opening, right? The B is still going to be from the center, B to the left, and B to the right, but those are your co-vertex, okay? So that's just the information you can get from the formula. But that's actually what we need, because guess what? With the vertex, the co-vertex, you have enough information. Make sure you draw, your horizontal lines all the way through and your vertical lines all the way through. They intersect and they become this sort of rectangle, right? That's what we need. And with that rectangle, of course, when we draw lines on the diagonal, that gives us our asymptote. And notice that I'm just getting more and more information just based on a general formula. Well, once we get the asymptote, we have the vertex, we have the co-vertex, we have the asymptote. Now we can sketch what the graph looks like, because we already know where it's opening, we know the vertex, and boom. Just make sure we draw it as close to the asymptote as possible without touching it, right? And just like that, we got all the information we ever need, right, regarding graphing hyperbolas. Now, this one I said is a more generalized form. Let me show you the actual general formula of hyperbolas. All right, so here's the more generalized, or at least the most generalized I've seen, equation of the hyperbola. Notice it's very similar to the other generalized form, except for this one now you have your h and k. And luckily from all of our previous experience working with circles, working with ellipses, we can guess what h and k is. And you are most likely correct, right? H and k is the point of the center. Now, the one thing that I do want to point out that we have to be very careful of in this case is that notice that, remember, when they flip, right, the h and k follows suit. So when you see something like this where the y is in front and it's positive, don't immediately assume, all right, the first one, that must be the x coordinate, the second one must be the y coordinate, and just go like that, right? That's not the case. You're going to make an error in this case, right? Wherever the y is, the k follows. That's always going to be the y coordinate of the center point. And wherever the x is, the h follows. And that's always going to be the x coordinate of the center point. So you see it here when it's opening left and right, where it's just going to be the standard. H is always going to be on the left, k is on the right. But if it's opening up and down, you have the k first, then h. Don't get that confused. Just remember where the x and y is. And actually, I think overall that's the key for both ellipses and hyperbola. Without having to memorize all those formulas, always pay attention to where the x and y is. Everything else is relating to that, right? In this case, the co-vertex and vertex follows where the x and y is, whether it's going up and down from the center or left and right from the center. The center point itself, the x coordinate, y coordinate, is based on where the x and y is. If it's following the x, x coordinate. If it's following the y, y coordinate. So there's your generalized form. Don't like it, understand why we need it, but just so you guys experience it, and of course, be very careful because different textbooks and different introduction have very different variations of basically the same thing. So now that we've seen this, we know roughly how to sketch it. Let's just go over a few examples and actually draw the graphs, getting information so that we just get a little more practice and comfortable with what we are given and what we can do with it. All right, so let's start off with this again. And yes, oh my God, we're just like beating this to death, right? So here's the thing. We went over this. We know roughly what it looks like, but I want you guys to see how we get the information. Notice that we're going to glean very similar information because they're almost exactly the same, but it ends up being very different graph just because of minor changes. Well, here's the thing. Okay, cool. Let's look at this. No center. Both of them, their center is going to be at 0, 0, right? Based on our remembrance of the formula if you want, but just notice that there's nothing with the x and y. So the center is going to be 0, 0 for both. Cool. And then we also notice that, well, actually, I'm wondering if you guys can actually see the words, but let's just keep it at black marker so it's easier to see. We have our co-vertex and vertex, depending on which equation we're talking about, right? As basically not 9 and 4. remember in the formula itself it's squared. So technically it's a 3 squared and 2 squared. 3 squared and 2 squared. So it's actually 3 and 2, right? That's not correlated in any way. It's just one of them is going to be 3, one of them is going to be 2, depending on the equation itself we're talking about. And just make it like that. All right, cool. So we have our co-vertex, our vertex, and we have our center. That's basically all we need. Oh, one more thing. Make sure that it's always 1, right? If it's not, then we got to make sure that we format the question or the equation itself into 1 so that we can actually graph it. All right, cool. So here we go. All right, let's just start off with this, and I'm going to draw 2 graphs that are basically very similar. Okay, so we have our coordinate planes, and we have our co-vertex and vertex as 2 and 3. Well, in this case, let's just look at this. Okay, so here, since this is going to be under the x, where there's the 3 squared, we actually are going to go here from the center, right? Our center is 0, 0, 3 over, and 3 over, which gives us -3. And of course, we have our 2, which is under the y, is going to go up 2 and down 2. Not drawn to scale. Okay, same thing here, except for the 3 is under the y, so actually this is going to be 3 here, -3. 2 is under the x, it's going to be -2 here, 2. Okay, so notice we're getting very similar information, right? But based on where it's located, if it's under the x or under the y, then, well, it's going to be located in the x or y axis, right? So there it is. Okay, cool. Now that we have our co-vertex and our vertex drawn, we can make our basically little rectangle. And of course, this is really not drawn to scale in any way because my 2 seems to be longer than 3's. But there we go. Okay, and this one's going to be right here, right here, right here, and right here. Once again, we have our little rectangles. And then afterwards, we draw our asymptote, which is just going to be the cross from the diagonal. And there it is, right? There's that. Same here. There is that. Okay. All right, cool. What else? Well, that's basically all we need. Remember that depending on which one is positive. In this case, the x is positive, so we know it's opening this way. That means we know these guys right here, the 3 and the -3 are our vertex. So from there, we're going to draw sort of a curve that's very close to the asymptote. Like that. Same this way. Down there. There it is. Okay. This one, the y is positive. So rather than, opening left and right, we're going to be opening up and down. So we know that this one is our vertex, and this is also our vertex. So from here, open up this way, close to the asymptote. Same here, the bottom, open down this way, and this way right there. And just like that, there you go, 2 graphs, right? One opening left and right, one opening up and down, all getting the same information. The center is still 0, 0, the co-vertex and vertex is still the numbers 3 and 2, but based on their placement in relation to x and y in the equation, right? It's either opening left and right or up and down. So hopefully this clarifies how to get the information, what to expect, and from there how to sketch this graph. Let's look at another one. All right, so here's 2 other equations. Now, if you guys can see it right away and it's screaming to you, great. You already know what's going on, what the relation between these 2 equations are. If not, that's entirely fine. Let's just look at the easier one and work with the easier one first. Notice this. As tempting as it is to just get started and start getting information, one, it doesn't look exactly like our equation of a hyperbola. And the other thing is, notice that this is not 1. So in order to make sure that everything works out, we must divide this by 16 on both sides to ensure that everything becomes 1 in this case, right? So we're going to divide by 16, divide by 16. So this one right here, 4 over 16 is just going to be simplified to x squared over 4. And this is going to be minus y squared over 16 equals 1. There you go. Now it looks more like the equation of a hyperbola. Okay, so in this case, what can we glean? Well, we notice that this is just 2 squared. This is 4 squared. Okay, that's good, right? we know that in this case, there's nothing interfering with the x and y, so that center is going to be 0, 0. Cool. Well, in that case, we basically have almost everything we need. We draw our graph. We know that the vertex, co-vertex is going to be 2 and 4, but we have to pay attention. 2 is under the x, so in this case, it's going to be, here is going to be -2. Here's going to be 2, right? And the 4 is under the y, so up here, I'm going to try to be a little more accurate. Here's going to be 4, and here's going to be -4, okay? There's our vertex, our co-vertex, and now we can draw our lovely rectangle right here that crosses the co-vertex and the vertex. There it is. Okay, boom, right? And just like that, we can now draw our, wow, that was terrible, asymptote that crosses the diagonals. Okay, and then from then, we can sketch this, right? X is the positive, so it's going to be opening from left and right. So that means we know that this one right here is our vertex, this one here is our vertex, and then we just draw curve that are close to the asymptote. Just like that, right? Notice that it gets a lot quicker once you start building experience and being able to get the information needed immediately. Well, this one right here, what do? Well, the lovely thing about this is that it looks very similar to this. So you can sort of guess. If we divide by 16 on both sides to ensure that this side ends in 1, what we basically have is going to be x minus 2 squared over 4 minus y minus 3 squared over 16 equals 1. Very similar to this guy. But now we have this right here and this right here as the difference. So you can guess the center is not 0, 0 anymore. The center is now, this is following the x, so that's going to be 2. This is following the y, it's going to be 3. Other than that, everything else is the same. So if I wanted to graph this, what would I do? Well, I'm going to draw this right here, and rather than just starting at the center and then moving left and right, we actually have to find the center. This is going to be on 2. 1, 2, 1, 2, 3. This is where the center is. And this is one where it gets a little peculiar, but the information luckily is still the same, right? The vertex itself is going to be on the 2, right? Co-vertex is 4, but then when I say 2, it means 2 over from the center. So in this case, right, 2 over, this is where it's going to be one of the vertex. This is going to be where the other vertex is, right? 4 up and down is going to be, well, 1, 2, 3, and then 4 is going to be down here about, and then of course it goes up. It's going to interfere, but 1, 2, 3, 4 about, let's just say right here. Okay, so notice that once again the center is here now, not in the origin. So we just moved everything. All we did was just shift everything. But other than that, the procedure is still the same. All of a sudden we have this lovely rectangle right here. Then we have our asymptote, right? And then from then on, from these vertex, we draw our curve. So it's the same graph except for shifted based on where the center is. That's all. It's just grab this guy, moved it up, or moved it over 2, and then up 3. Just like that, right? So hopefully this clarifies it even more, knowing that you're not always starting at the origin. You just start at the center point, wherever the center point is located, and then move based on your co-vertex and your vertex. So let's look at one more. All right, so there you have it. This right here just covers the very basic on graphing hyperbola, right? We went over definitions, which is good because it's actually necessary, especially when you encounter problems like this that just requires you to understand the definition, right? We went over that, how to get the information from the equation itself and just graphing it. Now, the other thing you would encounter when talking about hyperbola is when they're asking you to actually find the coordinates, right, using mathematical calculations. And we haven't covered that much in this video, but luckily for us, if we understand the concept, and I'll most likely do it in a future video where we will be calculating and going through how to get the actual I guess you could say points, foci, and so on and so forth with hyperbola. It's just a really long and I guess you could say filled with information sort of topic. So I didn't want this video to go on too long. Anyways, hopefully this is helpful. Luckily for us, you know, it's just a graphing of two parabolas, up and down, left and right, based on asymptote and square. So thank you for watching this video. Please like, comment, and subscribe. I will see you in the next one.